Hey, welcome back, Algebra 2 students. Today we're looking at systems word problems, our favorite. We're going to be working on word problems. We're going to be developing your word problem solving skills, and we're going to hopefully make it less daunting to do. It's going to be a little bit easier once we know what we're looking for and how to set up our problems. Because you will be asked to do these on your end of course exams and the tests throughout the year. We just want you guys to get a little bit more comfortable in doing the word problems because they're valuable. They're not just complete the steps and find the answer. You're gonna have to like think it through, analyze your answer, do all those things. So just some hints before we begin. We want to define variables, and we'll see how that looks in just a second. We're gonna read our word problems carefully, and we're gonna translate our word problems into equations. And then we're going to use the best method to solve. So we already did substitution, elimination, and graphing. So whichever one you guys feel comfortable with, depending on the situation, you guys just use that. I'll probably just pick one. Probably not the graphing one because you guys know how to graph and you can go back. And if you choose to graph, you could do that pretty easily. So for the sake of today's assignment, we'll just do either elimination or substitution. And then if you feel like you need to do graphing or want to do graphing, then you can feel free to do that in your assignment. All right, so let's go ahead. The first problem says the sum of two numbers is 55. One number is 4 times as large as the other. Find the numbers. Okay, so here we go. The first thing we want to do is we want to define the variables. So it's asking us at the very end, find the numbers. Okay, so what are we looking for? We're looking for two numbers. Okay, so because we're not told what those numbers are, we'll use variables here. So let's say the first number, and you can choose whichever variable you want, but I'll just use an x. And the second number we'll say is y. Now keep in mind we can't use the same variable for both of these numbers because they're two different numbers. Okay? So we've defined our variables, right? Define variables. So that when we go back later, it's going to be a lot easier. And when we're setting up our problem, it'll be much easier to set up. Okay, so it says, the first sentence says the sum. So the sum tells us that we're adding the two numbers. And that's going to be, anytime we say it is, that means equals 55. Okay, so let's write this in algebraic form. So the sum of the two numbers, so the first number is x, and the second number is y, and we're adding them. So that takes care of this whole first part, the sum of two numbers. Now we have the is, which we says is equals, and then our 55. Okay, so the first sentence helped us to set up our first equation. X plus y equals 55. Okay, the second part says one number is 4 times as large as the other. So one number, so either one of them, is means equal. So let's say x is the number that's equal to 4 times as large as the other number. So we have x equals 4y. Now we have our system of equations, right? We have two equations with the same variables. So we did step 2, we set up our equations. And then we're on to the next step where we're going to solve. So notice we have x equals 4y. So what I'm going to do here is I'm going to use substitution. So we're going to substitute our 4y in for our x. So we have 4y plus y equals 55. Right? Again, we're just taking our 4y because we know 4y is equal to x and substituting it in for our x in the other equation. So let's clean this up. Four y plus y is 5y equals 55. We're going to divide by 5. So y is 11. Okay, remember we have to go back and substitute back into one of the equations. I think the bottom one's a lot simpler than the top one. It doesn't matter, but just choose one. So we're trying to find x now, and we know that y is 11. So 4 times 11 is going to give us 44. Okay, so what are the two numbers? The two numbers are 11 and 44. And just to check, right? If we add them, we get 55, correct? And one number is 4 times as large as the other number. 44 is 4 times 11, so this works out. So it's always nice to go back at the very end and check to see if it comes out correctly. Okay, on to the next one. It says a fruit company delivers its fruit in large and small boxes. 2 large and 12 small boxes weigh 199 kilograms, and that 5 large and 3 small boxes weigh 133 kilograms. And it's asking how much does each type weigh. Okay, so it's asking how much does each type weigh. Each type of what? Okay, well that's in the first sentence, right? We have 2 types of boxes. We have large boxes and we have small boxes. So let's set up our variables. So let L equal large boxes. Notice I wrote a cursive L because if I write just a regular script L, then it might be confused for a 1. Okay, and then let S equal small boxes, because those are the two. Oh, we should probably say weight, right? Large boxes weight and weight, right? Because it says how much does it weigh. Okay, so we have our variables set up. That's step 1. Step 2, we're going to read back through here and then try to set up our equations. Okay, so step 2. Well, the second sentence says 2 large and 2 small weigh 199. So if I say 2 times the large weight, and then I add on 12 times the small weight, that should equal to 199 kilograms. Okay, and then the third sentence says 5 large and 3 small weigh 133. So 5 large plus 3 small is equal to 133. Okay, that's step 2. Step 3, we're going to solve, right? So we have to decide which way we're going to solve. Notice that in this case, all our L's, S's, equal signs, and constants line up. So, and we don't have just y equals or x equals, right? So we're going to go ahead and solve this using elimination. This is a little trickier one, but if you do this correctly, we can do this one by only changing one of the equations. So I'm looking here at our S's, right? 2 and 5, well, for our L's, 2 and 5 don't have any common factors. We'd have to multiply by each other here, so we'd have to end up changing 2 equations. But I know that because for our S's, 12 and 3s, we can just multiply 3 by -4 to get -12, which is what we want, so we can eliminate. So we can do this by only changing one of the variables, or one of the equations, I should say. So the top is going to stay the same, but the bottom we're going to multiply by -4. So -4 times 5L is -20L. -4 times 3s is -12s. And then -4 times 133, I need a calculator here. So 4 times 133 is 532 negative. Now here, because we have 12s and our -12s, those cancel out. And then we're adding, right? So 2 plus -20 is -18L is equal to -532 plus 199. which is negative 333. I don't know if this is going to come out nicely, but let's go ahead and do this. Divide by negative 18. And then this is going to be, the large box is going to be 18.5 kilograms. Remember, we have to find the large and the small boxes. So then the small boxes, let's plug it into the top one. That looks like a little bit easier. So we're going to do 2 times the large box was 18.5 plus 12s equals 199. So 2 times 18.5 gives us 37. And then we have a 2-step, so we're going to subtract, 37 on both sides. So 12s equals 199 minus 37 is 162. And then dividing by 12, 13.5. 13.5. Okay, so our small boxes are 13.5, our large boxes are 18.5. If you want to check, go ahead and plug these numbers back into both equations and make sure they come out true. Okay, so same idea. We're defining our variables, we're setting up our equations, and then from there we're deciding, okay, do we want to use elimination? Do we want to use substitution? If you want to use graphing, you can do that as well. Okay, on to problem 3. So this one says a phone company has 2 plans. So this is kind of old school because back in the day they used to charge a monthly fee, and then they used to charge per minute of calls, which could be a hassle if you talk for a lot of time on the phone. So yeah, they charge per minute. Now everybody's unlimited minutes, unlimited call and text and stuff. But yeah, back in the beginning days of cell phones, it cost you per minute, which kind of sucks. Plan A for this company has $9 a month plus $10 per minute of calls. And then plan B is $20 per month plus 8 minute per calls. 8 cents per minute of calls. Okay, so it's asking us to do 2 things. When are the 2 plans the same cost? And what is the cost when they're the same? So we're looking at 2 variables here, right? So the first thing that could change is the minutes. So I'm going to say let M equals the minutes. And then the second variable that we don't know is the cost. So we're going to say let C equal cost. Okay, so this is step 1. We set up our variables. Step 2, let's set up our equations. So remember the A and B are the cost, right? So we're going to say for plan A, the cost is equal to $9, that doesn't change, plus 0.10, 10 cents per minute. And then for plan B, the cost is going to be $20 plus 0.08, which is 8 cents per minute. So pretty straightforward here. Technically, for this one, we could do it anyway. I think that because we have C equals, right, we could set it up as an elimination for both of them. Everything lines up nicely. But I think substitution is a little bit easier in this case. So we're just going to substitute one into the other, because we know that C is equal to both things. C equals 9 plus 10, 0.10 m, and 20 plus 0.08 m. We can set them equal to each other. So we're going to say that I'm going to take this one and substitute it in for C here. So 20 plus 0.08 m is equal to 9 plus 0.10 m. Another way to think about it is because c is equal to both of them, we can just set the 9 plus 0.10 m and 20 plus 0.08 m equal to each other. Okay, so let's do this. Let's move our 0.08 minutes over. At the same time, I guess we can move our 9 over. So 20 minus 9 is 11, and 0.10 minus 0.08 is 0.02 m. And then we're just going to divide by 0.02 to get our m by itself. And then 11 divided by, 11 divided by 0.02 is 550 minutes. So 550, oops, that's too many fives. 550 equals our m. So we answered the first part when. So 550 minutes. Now in order for us to answer the second question, we gotta substitute it back in. So I think the top one looks a little bit easier to work with. So we're gonna substitute it into c equals 9 plus 0.10 times m, which we found is 550. So this is gonna be c equals 9 plus 0.10 times 550 is 55. So the cost would be 9 plus 55, which is $64. So we answered the second part. So part A, 550 minutes. If we talk for 550 minutes on either plan, we end up costing $64. Okay. On to the last one. The last one's a little bit tricky, and this is one of the problems that you might see in science, in physical science or physics, because there's some stuff going on here. So there's this boat, right? And it travels upstream. And what upstream means, upstream means is that the stream is actually working against it. So the speed of the boat is going to be decreased because the speed of the current is pushing against it. And then we have the same boat, this time going downstream. And downstream means that the current's actually helping it. So it's going to go faster because it's pushing the boat downstream as it's traveling downstream. Okay, so let's read this whole problem. So it says a boat travels 406 kilometers in 7 hours going upstream and 846 kilometers in 9 hours going downstream. So what's the rate of the boat in still water and what is the rate of the current? So if you guys have had physical science, then you should probably recognize D equals RT. And what that means is the distance is equal to the rate times the time. So let's go ahead and start defining variables here. Okay, so we have two variables here. And it's going to be a little bit tricky, but let's say that let's say X, because it's hard to define. Actually, no, let's say B. Let B equal the boat's speed. Okay, because it's asking us how fast is the boat going in still water. And the second one is the rate of the current. So let's say let C equal the current speed. Okay. Now here's the tricky part. When we're setting up our equation for this type of problem, we know the distance for each of them, right? So the first one, when it's going upstream, the distance is 846 kilometers. Oh, sorry, 406 kilometers. We also know the time. Okay, so let's set up this first equation, and I'll show you why the rate is a little tricky. So the distance is going to be 406 kilometers. The rate is a little bit tricky. So because we're going upstream, right, this picture here, we're going to have the boat speed minus, right, because the current is pushing against it, C. And that's going to equal to that multiplied by our time, 7 hours. Okay, in the second scenario, this time we traveled 846 kilometers. And this time the rate in this picture going downstream, the current is helping the boat. So we're going to say plus C. The current is speeding the boat up. And then this took 9 hours. Okay. So the setup of these ones are a little bit trickier. Now let's clean this up a little. Let's go ahead and distribute before we start solving. So 406 equals 7b minus 7c. And then 846 is equal to 9b minus 9c. So if we have to solve this using substitution, it'd be hard because we don't have just a b or just a c in here. So let's go ahead and do it by elimination. Unfortunately for this one, we're going to have to change both of the equations because 9 and 7 have no common factors, or we can't get to 7 from 9 or 9 from 7. So let's just multiply. And it doesn't matter which one you choose, but I'm going to choose to do the b's. So let's multiply the top by 9. And let's multiply the bottom by -7, just so that we can eliminate. So I'm probably going to need our calculators here. So 9 times 406, 3654. So this one is 3654. And then 9 times 7b is 63b. And then 9 times 7, oh, this one should be a plus. Sorry, because we have the plus here. And then 9 times -7 is -63c. Now let's go to the bottom. So -7 times 846. -5922 is equal to -7 times 9b is -63b. That's what we want, right? So we can eliminate. And then -7 times 9c is -63c. All right, so let's add these things up. So 3654 minus 5992 is -2268. The 63b's are going to be eliminated because we have a positive and a negative. That was the point of what we're doing. And then -63 minus 63 is going to be -126. Be careful there. And then we're going to divide by -126 to get our C. So -2268 divided by -126 is 18. So C equals 18. So what is the rate of the current? That's 18 kilometers per hour. Now we have to go back and figure out how fast the boat goes. So we can choose either of the equations. I think the top one's a little bit easier. So we're going to do 406 equals 7b minus 7 times our current, which is 18. 7 times 18 is 126. And we're at a 2-step here. So we're going to add 126 And then 406 plus 126 is 532. And then we just have to divide by 7. It's 76. So our boat is traveling 76 kilometers per hour. That seems pretty fast. I mean, it works out, but 76 kilometers per hour, how much is that? I need to Google that because I need to wrap my mind around it. So 76 kilometers per hour, 2 miles per hour. So it's 47 miles per hour, 47 miles per hour. That's pretty fast. That boat is booking it. It's probably a speedboat. Okay, but yeah, that's our answer. Just keep in mind there's also one with planes that are going against the wind and with the wind. So make sure the with the wind part is plus the wind current, and against the wind is minus the wind current because it's going to speed it down. And yeah, as long as you do a few of these ones, then you get a little bit more used to them. And then the math on it, again, you can choose to substitute or eliminate or use graphs, right? So that part shouldn't be too hard because we have a lot of practice in that. All right, good job today, guys. Again, see you next time.